Hi everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering. In this session, I'm going to discuss about eutrophication of lakes. So, in this session, I'm going to discuss about topics or introduction to eutrophication, types of eutrophication, sources of eutrophication, and what are the effects of eutrophication, and what are the examples of eutrophication, how to control the eutrophication, and conclusion. So, first, introduction about eutrophication. Eutrophication, it is a Greek word. It in Greek sense, eutrophia meaning nourish well. Eutrophication, it is derived from Greek word that is eutrophia. So the meaning of eutrophia is nourish well, or more precisely hypertrophication. Hypertrophication, it is a enrichment of water body with nutrients. So here eutrophication, it is more precisely hypertrophication. Hypertrophication means it is the enrichment of water body with nutrients. Enrichment of water body with nutrients is called as eutrophication. So this process, it is induces growth of plants and algae and due to the biomass load. So this may result in oxygen depletion of the water body. So this may result, so due to this eutrophication, it will lead to the oxygen depletion in the water body. And this process induces growth of the algae as well as plants in the lakes. So one example of this bloom is the bloom or great increase of phytoplankton in water body as a response to increased levels of nutrients. So here example of this type of eutrophication is that, so here bloom or great increase of phytoplankton like plants, so in water body is as a response to increase in levels of nutrients. So it is an example of eutrophication process. Eutrophication, it is generally induced by the discharge of phosphate containing detergents, fertilizers or sewage into aquatic system. Eutrophication, it is generally induced by discharge of phosphate containing detergents, fertilizers or sewage into the aquatic system. So when discharge of phosphate containing detergent, fertilizers or sewages are into the aquatic system, this type of eutrophication occurs. So because it will lead to the increased levels of nutrients. So this may result oxygen depletion of water body, and this may induce the great increase of phytoplankton in water body. So this is our introduction about eutrophication process. So next topic is types of eutrophication. Types of eutrophication. Natural eutrophication is the first type is natural eutrophication. So although eutrophication, it is a commonly caused by human activities, it can also be a natural process, particularly in lakes. So although eutrophication, it is a commonly used by human activities, so it is commonly caused by human activities, it can also be natural process. So particularly in lakes. So here the paleolimnologists so now recognize that climate change, geology, and other external influences are critical in regulating the natural productivity of lakes. So here they recognizes that climate change, geology parameters, and other external influence, these are playing a critical role in regulating natural productivity of lakes. Natural productivity of lakes. So some lakes are demonstrate the reverse process. Some lakes are also demonstrate the reverse process. So and it becoming less nutrient rich with time. So here in some lakes, it will leads to the high nutrients, and so some lakes these are becoming like less nutrient rich. So with the time, so here, so this is a natural eutrophication. It may lead to the high nutrients or low nutrients. So the main difference between natural and anthropogenic eutrophication, it is that, so the natural process, it is very slow, occurring on geological time scales. So the main difference is, the natural process, it is very slow. Natural process, it is very slow, occurring on geological time scales. So here, natural eutrophication, this may takes place by the human activities as well as natural process like climate change, geology, and other external influences. So other eutrophication process is, other type of eutrophication is cultural eutrophication. Cultural eutrophication, it is the process that speeds up natural eutrophication because of human activities. Cultural eutrophication, it is the process that speeds up natural eutrophication. So here natural eutrophication, it is because of human activities as well as natural process. So here cultural eutrophication, it is the process that speeds up natural eutrophication because of human activities. Natural eutrophication, it is because of natural processes like climate change, and pollution, and geological changes. So here, cultural eutrophication means it is the process that speeds up natural eutrophication because of human activities. Due to some of the reasons like urbanization, land runoff, it is accelerated, and more nutrients such as phosphates, nitrates are supplied to the lakes and rivers. So then to coastal estuaries and also bays. So, due to some human activities as well as due to some reasons like urbanization, and also land runoff, it is accelerated. So, it is accelerated, then the more nutrients such as phosphates, nitrates, these are supplied to the lakes. They are moved to the lakes and rivers. From the rivers, so they are moved to coastal estuaries and bays. So here the extra nutrients are these extra nutrients are also supplied by treatment of plants, fertilizers, farms, as well as untreated sewage in many cities. So this is cultural eutrophication. It is by human activities like urbanization, land runoff, and also so these are all the nutrients from the land runoff and this sewage. So these are moved to the lakes and rivers. Then they are moved to the coastal areas and also bays. So extra nutrients, these are also runoff. These are also moved by land or water runoff. So here, by the treatment of plants like agriculture, by uses of fertilizers in agriculture. So these fertilizers, farms, so these are giving extra nutrients to the uh, lakes. So this is cultural eutrophication. So here mechanism of eutrophication. So how eutrophication is occurring? So the eutrophication, it is arises from the oversupply of nutrients. Eutrophication, it is occurring here. It is arising from the oversupply of nutrients, which leads to the overgrowth of plants and algae in the lakes. Eutrophication, it arises from the oversupply of elements, so which leads to the overgrowth of plants and algae present in lakes. After such organisms die, the bacterial degradation of their biomass consumes the oxygen in water, thereby creating the state of hypoxia. So thereby this leads to the oxygen deficiency in the lake. So here the eutrophication, it is arises from the oversupply of nutrients. Due to this oversupply of high nutrients, so these are leads to the overgrowth of plants and algae present in water. So when they die, when the plants and algae die, so these are undergoing bacterial degradation. So for for the degradation of organisms, bacterial degradation, these bacteria they are consuming the oxygen present in water. So due to that, the oxygen concentration is decreases in the lakes. So the primary limiting factor for eutrophication it is phosphate. Primarily limiting factor for eutrophication it is phosphate. Phosphorus it is a necessary nutrient for plants to live. So and it is the limiting factor for plant growth in many freshwater ecosystem. So phosphate it is causing the growth of it will use for the growth of plants. So this is the limiting factor for plant growth. The availability of phosphorus generally promotes excessive plant growth and decay. On other hand, nitrogen in the form of nitrates also play a vital role in the eutrophication process. So here phosphates and nitrates are playing a crucial role in eutrophication process. Phosphates and nitrates adhere tightly to the soil, so it is mainly transported by the leaching and erosion. So phosphates and nitrates these are tightly adhered to soil. So these are mainly transported from the soil to lake by leaching process and also erosion process. So once translocated to lakes, once these nitrates and phosphates are translocated to lakes, the extraction of phosphate becomes tough. The extraction of phosphate becomes tough. So hence the difficulty of reversing the effect of hence the difficulty of reversing the effects of eutrophication. So here this is very difficult to reverse the phosphate to soil. So here the sources of these excess phosphates are phosphates in detergents, industrial or domestic runoffs, and emerging fertilizers. These are emerging as the dominant contributors to the eutrophication. Phosphates or nitrates are so these are present in detergents and industrial or domestic runoff fertilizers. These are emerging as an dominant contributors to the eutrophication. So, sodium triphosphate. So this is a one of a component of many detergent. Sodium triphosphate. It is a component of many detergent. It was a major contributor to eutrophication, enhanced growth of aquatic vegetation and algal blooms, disturbs some normal functioning of aquatic ecosystem, causing various problems. So in phosphates, sodium triphosphate, it is a major contributor to the eutrophication. It is enhancing the growth of aquatic plants and algal bloom, and it is leading to the various problems in aquatic ecosystem. So the water becomes cloudy with green or red or yellow shade. So the water which is having sodium triphosphate, it can become like cloudy with a green or red or yellow shade indicating algal blooms. So these blooms block the penetration of sunlight into the water body. So these blooms, this will stop the block the penetration of sunlight into the uh, deeper body, into the water body. So apparently the dissolved oxygen level in the water body also decreases. So that's why the oxygen levels decreases in the water body. The lack of oxygen kills the aquatic plants and animals. Lack of oxygen. So this kills the animals as well as plants which are present in aquatic ecosystem. Death of these organisms and life forms increases the level of organic and inorganic matter. Death of these organisms and life forms increases and the level of organic and inorganic matter. So which require a large amount of oxygen for decomposition. So now the depletion of oxygen level leads to the accumulation of nutrients unable to be decomposed. So now the depletion of oxygen level leads to the accumulation of nutrients unable to be decomposed. So slowly the aquatic ecosystem it is converted from aerobic to anaerobic condition. So increasing the number of anaerobes which apparently gives a pungent odor generally produced by methanogens sulfur bacteria. So because of lack of oxygen, the aquatic ecosystem it is converted from aerobic to anaerobic. So it is increasing the number of anaerobes. So which apparently gives this pungent odor which is produced by methanogens and as well as sulfur bacteria. So now this water ecosystem can no longer support life, also causing hazardous effects to the environment. Eventually, the aquatic ecosystem it turns into a bog, so it gradually converts into terrestrial ecosystem. So these are the effects of some effect of sodium triphosphate in aquatic ecosystem, and due to sodium triphosphate, eutrophication it is increasing as well as oxygen concentration is decreases. Due to that, this will leads to the increase in number of anaerobes. So this will give pungent odor, so which is produced by methanogens as well as sulfur bacteria. So this is so here as time increases, so nutrient load up. So the excessive nutrients from fertilizers, these are flushed from the land into rivers or lakes by rainwater. So as time increasing, first these excessive nutrients from fertilizers, and also so these are flushed from the land into the rivers or lakes or by rainwater. So second, these pollutants cause aquatic plant growth of algae, so duckweed and other plants. So algae blooms, oxygen it is this second process. Third process is algae blooms takes place, also oxygen depletion also takes place. So algae blooms preventing sunlight which are reaching other plants. So here the plants die and oxygen in water it is depleted. So here the decomposition of further depletes oxygen. So dead plants are broken down by bacteria decomposes. So using up even more oxygen in the water. So here, so fifth one, death of ecosystem takes place. So oxygen levels reach a point where no life is possible. So fish and other organisms can die because of no loss of oxygen percentage in water. So this is the eutrophication effect. This is the eutrophication effect. So what are the sources of eutrophication? So here two types of sources are there: point sources and non-point sources. Point sources are directly attributable to one influence. So in point sources, the nutrient waste travels directly from source to water. In point source, the nutrient waste travels directly from source to water. Point sources, these are relatively easy to regulate. Non-point source for pollution, it is that which comes from diffused sources. Point sources, in this nutrient waste, it is travels directly from source to water. In this non-point source, for that nutrient waste, it will comes from diffused sources. So point sources, these are from wastewater effluents. This includes wastewater effluents, municipal or land industrial waste, runoff and leachate from the waste disposal systems, runoff and infiltration from animal feedlots, runoff from mines, oil fields, unsieved industrial sites, and these are including overflows of combined storm and sanitary sewers, and runoff from construction site, and also untreated sewage. So these are the point sources which will directly travels from source to water. Non-point sources, runoff from agriculture and irrigation, runoff from pasture and range, urban runoff from unsieved areas, and that's a septic tank leachate, runoff from construction sites, runoff from abandoned mines, and also atmospheric deposition over a water surface, other land activities generating compound contaminants. So these are the two types of sources of eutrophication. So here point sources and non-point sources. So what are the effects of eutrophication? Primary productivity increases and diversity of primary producers varies. So primary productivity it is increases, the plant growth is increases, primary productivity increases, diversity of primary producers varies. So diversity it is changes. So growth of aquatic plants and algae reduces the light of penetration and also increases the turbidity. So death of resident organisms takes place due to the eutrophication. Death of resident organisms takes place, only increase of producers like primary productivity it is increases, the growth of aquatic plants and algae it reduces due to light penetration, and also it increases the turbidity and it increases the depth of resident organisms, and DO level decreases, dissolved oxygen level decreases, and sedimentation rate increases. Due to dissolved oxygen level decreases, so the sedimentation rate increases. The decomposition of dead organism it is not takes place because of a low dissolved oxygen level. Species diversity it is altered. In turn, overall aquatic ecosystem is affected. Accumulation of organic and inorganic nutrients, accumulation of organic and inorganic nutrients, conversion of aerobic environment to anaerobic conversion of aerobic environment to anaerobic, in turn altering the appearance, order and water body. And anaerobes these are produce toxins, and usage of this water causes health problems. And also aquatic ecosystem it is depleted. Aquatic ecosystem it is depleted. Here anaerobes, so this can number of anaerobes this increases, and aerobics decreases. So because of that we can get the different order to the water body, and then due to this aquatic ecosystem it is depleted. These are the effects of eutrophication. So, what are the examples of eutrophic lakes? So, Uday Sagar Lake, it is situated around 30 kilometers in the east of Udaipur. Uday Sagar Lake, it is situated around 13 kilometers in the east of Udaipur, revealed high phosphate content due to discharge of pollutants from surrounding phosphate mines, chemical factories, distillery, and domestic effluent. So Uday Sagar Lake, it is situated around 13 kilometers in the east of Udaipur. It is revealed that high phosphate content due to discharge of pollutants from surrounding phosphorite mines and chemical factories, distillery, and also domestic effluents. This lake shows a green shade of algal bloom witnessing eutrophication. The lake shows green shade of algal bloom, so witnessing eutrophication, it is witnessing eutrophication. So next example is Dal. It is a lake in Srinagar. Next example of eutrophication lake is Dal. It is a lake. In it is in Srinagar, which is named as the jewel in the crown of Kashmir. Which is named as jewel in the crown of Kashmir. The lake is also important source of commercial operations in fishing and water plant harvesting. And the lake covers an area of 18 square kilometers, and it is a part of natural wetland which covers 21.1 square kilometers. Due to increasing urbanization, industrial discharge, and use of chemical fertilizers in and around the area has resulted in the pollution of lake, causing eutrophication. So due to increasing urbanization and industrial discharge, so the use of chemical fertilizers, so these are the resulted the pollution and it is resulting in the eutrophication of the Dal Lake. So, how to control the eutrophication means the role of nitrogen and phosphorus is overwhelming in the eutrophication process. So, which needs to be controlled and effective measures need to be taken. Sources of nitrogen and phosphorus need to be checked and prevented from entering water body. Sources of nitrogen and phosphorus need to be checked and prevented from entering to the water body, and timely removal of sediments and overgrown aquatic plants from the water bodies. Stimulation of algal food web. Stimulation of algal food web. Industrial or municipal and domestic outflow need to be treated prior to releasing. So use of fertilizers to be avoided and physiochemical methods to be adopted for the removal of excessive dissolved nutrients. So that is nitrogen testing to be done. So next one is nitrogen testing to be done. Physiochemical methods to be adopted for the removal of excessive dissolved nutrients, and chemicals such as alum, lime, sodium aluminate. This can be used to reduce the level of contamination. Chemicals such as alum, lime, sodium aluminate. This can be used to reduce the level of contamination. However, halting of eutrophication is very difficult, but can be temporarily controlled to some extent. So we can control for some extent. So this is temporary. We cannot. This is the very difficult to remove the eutrophication process. So these are the controlling methods of eutrophication. So conclusion. So coming to the conclusion, human-induced eutrophication has heavily degraded freshwater systems worldwide by reducing water quality and altering the structure and function of ecosystem. Human-induced eutrophication has heavily degraded freshwater systems worldwide by reducing water quality and altering the structure and functioning of ecosystem. With the demand of freshwater sources expected to increase substantially, these anthropogenic influences have severe environmental and economic repercussions. So here, the first obvious step toward protection and restoration of lake is to divert and or treat excessive phosphorus inputs via nutrient lodging restrictions. Living organisms can be used as monitors of trophic status of lakes. Nitrogen testing to be done to avoid the use of nitrogenous compounds. Phytochemical tests can be achieved to remove excessive nutrients, and effluents and runoff of water into lake need to be treated. It lakes very it takes a very long time to overcome the problem of eutrophication, but can be minimized to substantial level by incorporating some of preventive measures. So that's why we have to take some preventive measures. So to minimize the eutrophication. So we cannot overcome the problem of eutrophication, even though by using some preventive measures we can minimize the effect of eutrophication. So this eutrophication. So that's why we have to use some preventive measures and some preventive methods. So this is about eutrophication of lakes. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.